Welcome to Abhiravian videos. In this videos, we are going to find the value of pi using trigonometry. Come, let's go and see the video. What is pi? Pi is a constant. It is a constant between the perimeter and the diameter and the perimeter of a circle. So when you know the diameter, if you want to calculate the perimeter, you have to use pi. Multiply the diameter into pi, you will get the perimeter. So pi is a constant, and this is the diameter of the circle. And if you want to know the perimeter, then you have to multiply the diameter with pi, you will get the perimeter. This all we know very well. The value of pi is approximately 22/7 by fraction by decimal 3.142 approximately. There is no exact value of pi. We can get only the nearby approximate value of pi. So pi has been known for almost 4000 years or more than 4000 a year before Christ, 2000 years. So many mathematicians tried to find the value of pi and they could not get the exact value. They could able to conclude with the approximate nearby value of pi. So the ancient Babylonians, Egyptians, Archimedes and Zhu Zongzi, the famous mathematician of Chinese mathematician, and many more mathematicians tried to find the value of pi, exact value, but they could not. They could reach only the nearby value. So how they calculate the pi? There are many methods to calculate the value of pi using the measurement of the circle. By using a string or a twine and keep the twine over the circle and find the length of the twine, and by that they calculated the diameter of the circle and calculated the pi. And using an infinite series, using Buffon needle problem, using a limit, using a arc sine function, inverse sine function. So many methods, many mathematicians tried to find the value of pi. But in this video, we are going to find the value of the pi using our own method, trigonometric ratios and Pythagoras theorem. So this image I have used to calculate or draw the image used Excel spreadsheet. So you can also do this the same way by using Excel spreadsheet. You can also draw the image and do the calculations. Now let me explain how I have made this. First, I have drawn a circle OP with the radius OP. So O is the center, P is the border. I have drawn a circle. This is a close-up value of the part of this part only, not the complete circle. So for our calculations and for our understanding, this area is enough. So this is the center of the circle. This is the border of the circle. OP is the radius of the circle. Let us say the radius is 1. Let us assume 1 means 1 millimeter, 1 centimeter or 1 meter, whatever it is. Let us assume 1 centimeter is a radius OP. Then the angle between POP dash is 1 degree. Okay, practically 1 degree you could not see the gap between the angle because both will be very closer. OP and OP dash, both lines will be very close. You cannot see by our naked eye. But for understanding and illustrating purpose, I have keep the angle in this way. It may be 20-25 degrees, but for calculation, let us understand. Let us assume it is 1 degree. Radius is 1 centimeter. So when you draw these two lines, OP radius and OP dash is also a radius. Both are 1. Now in this circle, what we do, we draw a PQ vertical line to this OP dash. So this line cuts, this line meets at OP dash at Q. So we call this line as PQ. We draw a PQ line, it is 90° to this OP dash. So now it forms a triangle OPQ. OPQ, right angled triangle. So this angle is 1°, this angle is 90°, right angled triangle. So we know the radius, that is hypotenuse of this triangle 1, and we know the angle POP dash or POQ, angle is 1°. So now we can calculate by using sin theta is equal to opposite side by hypotenuse. So we know the hypotenuse and sin theta. So we can calculate using Pythagoras trigonometric ratios the opposite side. That comes 0.17452 opposite side centimeter. So if you know the hypotenuse and opposite side, then you can find the adjacent side by using Pythagoras theorem. So adjacent side is equal to whole the root of hypotenuse square minus opposite side square. So we have calculated by this way 0.999848 is the adjacent side OQ. So now we know the value of OP dash, that is 1, that is also a radius, and we have calculated OQ as 0.999848. So we can calculate this small area, that is called QP dash, 0.002 or somewhere in decimal values. So that is QP dash. This value we can calculate by subtracting from 1 minus this, we will get this. Actually this is 1 and this is 0.999848. So we will get this value. So now we know this side, the base and the height. Height is opposite side. So now we can come to this triangle. There is a small triangle. That triangle is QPP dash. That is a triangle, right angled triangle. So we want to calculate this hypotenuse of this triangle PP dash. So for calculating the hypotenuse of this triangle, this right angled triangle, we have the height and the base. That means we want to calculate this PP dash. So we know PQ and we know QP dash. So by using Pythagoras theorem, we can calculate and we will come to this value 0.17453. This value is the hypotenuse of this PQP dash triangle. So this right angle triangle, we get this value. This value is closer to this circle, the part of circle. When you see, it is maybe, if it is 1°, it is very close to that circle, same, almost the same value. So if you know this value PP dash for 1°, then you can multiply that into 360 degrees, you will get the whole circle's perimeter. This way we are going to, we have calculated this circle. So we have calculated this 0.17453,071 times 360. This is for 1°, this value, and if we multiply this into 360 degrees for a complete circle, so 360, we will get 6.283106 is the perimeter of this circle. So radius is 1, then diameter is 2. So diameter is 2, this circle's perimeter is 6.28316. So if you divide this perimeter by diameter, you will get a constant. That constant is pi. Pi is 3.1415, that is almost 3.142. So we have calculated the pi using the trigonometric ratios and Pythagoras theorem. So in the next slide, let us change this value. For example, radius 2, then diameter will be 4. Then what is a perimeter? By calculating this, we have come to this 12.56. So 12.56 divided by diameter, the diameter is 4, you will get the same 3.141553, that is 3.142, the approximate value of pi. We have received the approximate value of pi. So if you change, we will change in the same Excel the angle is 1 degree. So we change the angle. Let us see. Diameter is 4, actually perimeter, the radius is 2 and angle is 0.5 degree. If it is 0.5 degree, what we will get? We have to multiply by 720, because 720 times, if you arrange this piece 720 times, you will get a complete circle, because 0.5 into 360 into 2, so 720. So we will get the same diameter, 12.56, 3.14583. So 3.142, we can make it 3 decimal places accuracy. So 3.142. Now we get the value of pi by using trigonometric ratios and Pythagoras theorem. So we will do this with the Excel sheet. Let me explain you with the Excel. Let us see. Excel, where is my Excel? Okay, this here. In this Excel, you see 1. The radius is 1. Let us make this radius to 0.5, 0.5 centimeter. So the diameter is 1 centimeter diameter of the circle. We will get direct the perimeter value, the perimeter as a pi value, because the diameter is 1 into pi is equal to perimeter. So 1 into 3.142 is 3.14. So we get the value of the pi directly. So in this video, we have calculated the the perimeter of the circle by multiplying this value into number of times to make a complete circle. 1 degree angle means 360 times. We have multiplied by 360 times. So you can program the formulas by this way, and you can also find out with your Excel spreadsheet. Dear viewers, in this video, we have calculated the value of pi using trigonometric ratios and Pythagoras theorem. If you like our video, please subscribe our channel. Thank you for watching Abhiravin videos. Thank you very much.